Welcome back. Now we are going to continue from where we stopped earlier on, which is now we are moving to, we are done with the workplates. But have it in mind, we have not considered the joint, the two 50 mm by 100 mm, which is 2 by 4, that will be used to join the internal workplates at their meeting point, and they must be rigid. They must be jointed rigidly because of the expected imposed loads. Now we are moving to the tie beam. Tie beam now. Tie beam, we have decided to use 50 mm by 150 mm. Okay, we don't need to try this anymore. Now, our tie beam. As you all know, the tie beam will be across, it will be on the work plates. Across this way, be on the work plates. We need to know the number that will be needed, number of tie beam, number of points that will be needed, and the number of joints. The first one, let's consider the we have 12 meters width, and the length of this is 3.2. Do not forget, we are using 3.2 meter length as our length. So this 12 meters that has been done earlier minus okay, before we divide this, we are going to use this 3.2 minus the lapping, because we want to lap it. We are not joining it. We are not using another wood to lap both sides. We are lapping the two together. Or go this way. We are lapping them this way. So, but as for the work plate, the internal work plate, they will be joined. They will be parting together. Going to be parting on both sides. So this we are joining this way, and this will be 300. This will be 300. And this will be 600 rather. This is the minimum. 600. So we can divide both sides into 2. So they can both share. We are going to share 300. So that means this 3.2 minus 300. So that will give us 2.9. We've done that earlier. 2.9. So that is that 2.9 that we are going to use to divide our 12 to give us the number of members that are going to have here. So what would that give us? 12 divided by 2.9, 4.14. 4.14. The fact is that if we decide to use 4 and share the remaining this 1/4 is 140, which is less than 6 inches. So it means our lap, if we are using 4 members, means our lap will be about 22 inches each. It will be about 22 inches each. But at the same time, we have two options there. Is that we decide to maintain 4, or we go for 4.5, so that our lapping can be a bit more. The length of our lap can be increased a bit, and also we can decide to project our tie beam beyond the edge of our external and move a bit beyond it instead of it flushing. What we calculated is for it to be what flush with the external. We can decide to let it project by 4 inches more. So we have the discretion to use here. We have our discretion, and you can even say, okay, after the 4, instead of going for half, let's go for a third at 4.33. So that will be, it means 4 lengths, 4 full lengths, and 1 quarter. And the fifth one, it will be the fifth one will be cut into 3. That will give us about 1 meter plus. So it will now be used to make it up. That will be a very good option. So let's go for let's go for 4.3 numbers. Now, that means each of our lengths, it means this will be, this one typing will be, okay, very good. 1, 2, 3, 4 plus 1 small one here. So we have 4 full 1, 2, 3, 4 and 1 small piece there. So now let's now consider the number that we are going to have here. Then it's going to run this way. This is the way it will run. And whereas the Kingpost will be attached to it, likewise the Rafter. So how many of these do we need? So we know that our length is 24 meters. It's 24 meters. So that will now be 24 meters divided by what are we using as our spacing. The standard is to use a 1.2, and of course there are some specifications that might warrant us to use more than that, like 1.5. So but it's still better to use 1.2. If you are not even, in some cases you might even use 1 meter in some cases, but the average distance is 1.2. When we be using 1.5, it means the size of the members will be very thick, so that they can withstand any stress, any imposed stress. Now this is divided by 1.2. What would that give us? 20. We are going to have 20, but do not forget it should be 20. You must add plus 1. Where is that 1? You start from 1, 2, 3, 4. By the time you count to the last, it will still remain the last one. So we are using 21. Now this 21, the number of length required now, length required now be 4.3 times 21. What will that give us? 90.3. We have 90.3. Now we need to also consider waste. Maybe 5%. Let's consider 5% waste. We are not expected to have too much waste, but at the same time, it must be considered. Also, remember, it is all these remaining ones that will be needed, that will be used during the noggin, the internal noggin. They are going to be useful for scaffolding, both the internal and the leaves noggin. So they are going to be useful. So let's just do that. 5%. Add 5% of waste. Is a waste or off cut, or let's say off cuts. So 5% of 90.3 is what? That is 90.3 times 0.05. That should be less than 5. 4.51. So plus 90 plus point this, that was 94.8. That's approximately 95 numbers. So you can boastfully come here and add it. That's our tidying. Conveniently, you can say our tidying was 50 mm. Remember, if you are going to get this later, it's just a rough work. 50 by 150 mm. So it's still length. We are using how many? 95 at 1000. At the end of the day, by the time you want to share it, you might need to just add all our 50 by 150 together and indicate in the description 50 mm by 150 mm work siding, Kingpost, and Rafter. If the Rafter will be 150 as well. So just put the total instead of having this. But for the purpose of this calculation, let's be putting it this way. This is 1650 as well. Generally, the price of 3 by 4 used to be the same price of 2 by 6. Price of 3 by 4 used to be the same as 2 by 6. So what would this give us? 95 and 1650.
165,750.
165,750 naira. Okay. Now, our next one is what we are done with this. This is the Kingpost. That won't take us much time to take it over time. Let's leave it in the 3. Kingpost, which is 50 by 150 as well. Kingpost, the number, the Kingpost will be here. It will be at the middle. This way.
Yes, on top of the nail on the side.
So the same 21 number that runs is the number of Kingpost. So number required, number of Kingpost required is 21. Now, what is the height required? Height of Kingpost required. You don't know it yet. We need to calculate that now. But from the beginning, we said that we are describing 26.57 degrees as our pitch. Recall.
26.57.
Yes. Our pitch will be 26.57 degrees. So now, for us to determine our Kingpost, we need to take it of this now. This is one of the practical application of all the mathematics calculations, all those like Pythagoras theorem and the like. So do not forget, the Kingpost should be this way. It will be like this. This is the idea. The Kingpost will be made this way. The wall plate will be here. The wall will be here. Now one here. So now then our rafter will be this way. You can have a ridge here. So now this angle is what is known as 21 This is our theta. Okay, since we know it now is 26.57 degrees, we need here. So here, this point to this point, we need it. Of course, we know that which is our run. Which is our run. We know our span. Our span to be the width of the building, which is 12 meters. Our run will be what? 6 meters. 6 meters. So we are looking for this. Let's label this K as the king post. As soon as we will be needing this, let's label it R as our rafter. So now, because we are looking for this now, we can successfully what? We have this is unknown, so that won't be useful. So we have our theta. Okay, we are looking for our K, which is what? The opposite. This is the opposite. This is the opposite. Why this is the adjacent? This is unknown, this is known. We cannot use two unknown. So we have to use the one unknown and the other two have to be known. So in our so what I'm going to use now? We know that it's the tan. Therefore our tan theta equals opposite over adjacent, which is then our opposite in this case is what? Our Kingpost K over our 6 meters, our adjacent, which is 6 meters. Therefore, our tan theta, our theta is what? 26.57 degrees equals K over 6 meters. Therefore, by multiplying, our K is what? What's tan theta? What's tan 26.57? And just write it out, 0.557 degrees and times 6 meters equals 0.5 times 6 meters. Therefore, our K equals 3 meters. So our K is now 3 meters. So we said the length of the wood we are using 3.2, which means we are putting just one length will be enough for each of the Kingpost. And we need 21 of it, 21 required. Therefore, Kingpost required equals 21 times 1. One length will be enough for each of the Kingpost. It is 21 abi. Okay, we need to consider any waste. Yes, we need to consider. But 1 make it 22 length. But out of the 21, one might have been partly cut. So as well as there might be nuts there that cannot be ideal for that purpose. In fact, let us consider 2. 1 is not enough. Because we have to make as practical as possible. If care is not taken during the selection, we have a lot that will not be useful. Some might not even be up to the 10. The width might be enough, but the height, the length might not be up to the required length. So we need for us to join. So our Kingpost is style base 150 by 6 by 150 by 150 and 4 is 3 in length and number all our quantity 23. The rate is 2 by 6 is 1650, and that will give us what? That will give us 23 times 1650. Yes, 23 times 1650 naira. That's 37,900
150.
950. So, conveniently, you can forcefully say that we are good to go. We have done that. We are through with that. Now, we need to move to our rafter. We need to move to the rafter. The rafter. This will still be useful for us because you can now determine our rafter. Now, so we have two options. Is either to go for Pythagoras theorem. We now have our opposite is known, adjacent is known, the hypotenuse is not known. And we all know that the hypotenuse square is what? Opposite square plus adjacent square, which now means hypotenuse equals the root of opposite square plus adjacent square. Alternatively, we can consider the truss. Well, this will now be opposite hypotenuse. OH, that will be sine. So that will be sine theta equals opposite over hypotenuse. We may have to, well, I don't think we have to consider the two. Okay, let's do the first option, alternative. Let's go now. Rafter. What are we using our rafter? This stage we are using 2x4. That's 50 by 100, and then because we want to be conservative as much as possible. Yeah, we want to using let's use Pythagoras theorem. Pythagoras theorem. So r square equals 3 square in this case. We don't need to write square anymore. Plus 6 square. Therefore r
9 plus 36
equals root 9 plus 36. Which will be there we go, 5. That would be
6.7 or something.
6.7 meters. Our rafter. Now, before we move on, we can also use the look at track. That will be, we are looking for this. This is the hypotenuse. This is the hypotenuse. And we have this, we have the discretion to either use this or this. So that this H as what we are looking for. Let's consider the opposite. So this will now be so. So it means our sine theta equals opposite over hypotenuse. Our opposite here is what? 3. And our hypotenuse is r. Therefore, sine 26.57 degrees equals 3 over r. Yeah, what do we do now? Because multiply. So by the time you do that, this will go at the same. We later have to divide both sides by the coefficient of r. So alternatively,
r equals 3 over sine 26.
Okay, wait. What is our sine 23 point this? Yes.
26.57.
0.4.
Okay. 0.4 equals 3 over r. So you can say 0.4 r equals 3. Therefore r equals 3 over 0.4. So that will give us what?
7.4.
That's what?
7.5.
7.5.
I think this
Sine 26.17. It means this figure is not correct.
7. 3 divided by 7. It is not correct. So the answer should be 6.7.
Yes.
Yes. The sine 26.7 is 0.449.
0.449.
Oh, 26.57. Sorry.
Yes. 26.57.
0.447.
0.447. 0.447. So that will now give us, that will give us 6.7 meters. You can now see that, however, the same answer. So we have our discretion to use, we have discretion to go for anyone exactly. Now, don't let us forget that we have projection. It gives projection. What we have done is just up to this point. So we still have between here to here. We still have this to be added. We still have that to be added. So which is 0.6. So we can now say therefore length of our rafter now is 6.7 plus 0.6, which is 7.3 meters. So that's the length of one of the rafter. And the rafter will be nailed along at both the Kingpost and the tie beam. It should be in 21 because we have the tie beam and Kingpost in 21 places. It should also be 21 places and to be on the other side as well. So before that, let us determine how many length of wood we need to get this length alone. One length. How many length of wood we need to do that? By now, okay, let's do that. Since we know our the length of our wood is 3.2. That's without before lapping of them together. So, and do not forget our lapping is 600. So 300 will be removed from this, 300 from the other one.
That's 3 meters.
So now this will give us 2.9. Another thing, let us do the analysis together. Let's analyze these. Okay, now very good. You can see this here. We want to have this. So up to here, from here to here, this is 3.2. From here to here, 3.2. From here to here, 3.2. And from here to here is 0.6. From here to here is 0.6. So we want to determine the useful length or effective length of each of them. Out of the 3.2, by the time we remove this from each, we'll be left with 2.9 here. Here, in this case, we've left. So from here now, this one will be to here. Okay, to this place again, that will be 2.9 as well. Then this one will now start from here, and it's the last one, which will remain its own 3.2. It will remain its own 3.2. What I'm saying is this. This first one, from here to here, 3.2. By the time we remove 0.6 from it, we are going to be left with the effective one will be 9. 2.9. The same thing to this one. But this last one, because it is not continuous, this second one here will start from here up to, okay, yeah. This is the second one. From here up to here. Why the yes, from here. Okay, it starts to end here. Right? Starts to end here. Starts to end there. Which will be the same length as the first one. This is the first one starting from here, ending here. Though the lap is extending there, but effectively it's ending here. This one is starting from here and ending here, but the lap is extending to this space in this sense. So, in a nutshell, this last one will be 3.2, while these two will be 2.9, 2.9. If it continues, it is the last one that will be 3.9. But without stressing ourselves, we can so this is 2.9. No, this is 3.6 my 3.2 minus 0.6. 3.2 minus 0.6. That's 2.6. That's 2.6. 2.6. 2.6. So it means the length that we are going to use, we are going to this. So we are going to divide this 7.3 by this, by what? This 2.6. So that will now give us the number of length required. I will also consider another option, alternative. Consider another alternative. I think now we don't need this anymore. So the number of Rafter required, the length required, length required for Rafter is 7.3 divided by 2.6. What does that give us? What does that give us?
7.3 divided by
2.6.
2.8.
2.8, that's okay, 2.8, which is approximately 3 lengths. It means we are going to need 3 lengths for each to cover from the hypotenuse from the Kingpost up to this edge. Do not forget, we need to add our healing. So this 200 is very useful, so that by the time they want to heal this place to get the angle, they have enough clearance there. Alternatively, let's just divide our 7.3 divided by the length of our wood, which is 3.2. What do we have?
They have 2.28.
2.3. Now, plus, let us add our, this is 2.23. It means it's more than 2. So the joint we are going to have there, it means we are going to have 3 of these ones, 3 of the lengths. 3 lengths, but 2 joints. The joint will be 2. But if you have, we are going to have 2 full lengths and 1 off cut, 1 small one. So which means, very good. The meaning is this. Okay, let's just try it. We are going to have 2 full lengths like this. And then the third one will be small, like 1/3. So the meaning is that there will be 1 joint and another joint. That's 2 joints. So and our joint, our joint will be what? 600. So that's 600 times 2. That was 1.2. Okay. So lap, which is 0.6 by 2, as 1.2. So what I get here, 3.5. Okay, 3.5 length. So now we need to look critically. Why do we have different results, different answer? Why do we have that? Don't forget, I said there that the last one here will remain full. The last one here will be full. This one that will be 2.6. This other one too will be 2.6. But this one here has to be, because the lap, this middle one has already lapped it. So this will be 3.2. It will remain its own full length. Let's see. This is 7.3 as the length required by this. This was this. And the lap each length. Okay, if this is reduced by 3.6 plus 1.6, out to 0.6.